So the first sheet, you're going to make sure, I'm going to read the speaker notes and just drag it up so you can't see for a second. Follow the steps below. Be sure you have copied the documents into your digital notebook so that you may edit them. Drag and drop the definitions to the proper spaces on the images below. Use the arrows to place next to the wave to demonstrate increasing or decreasing in energy, frequency, and or wavelength. We should know this by now. That was a part of the lesson 1, understanding the relationship between the energy being carried in a wave by the frequency of the wave and or the amplitude. In this case, the amplitude is the same, but understanding that if amplitude is increasing, then wavelength is increasing or decreasing. You should be able to connect those two at this point. So those are the directions for this sheet. Basically, what you need to understand about light waves, which are electromagnetic waves, electro, which would signal like some sort of electricity, or light in the sense. We know that the natural light comes from the sun, so it's like an electromagnetic spectrum of light. And yes, that comes directly from the sun, which we are able to manipulate as humans to use to our advantage, right? But it is a natural phenomenon that occurs from the light waves that are being sent or that make it through our atmosphere from the sun. So we have it's called light energy or the electromagnetic spectrum, EMS. And these are the definitions on the side. You're going to make sure, remember, you can always zoom in if you can't see something, drag it over. You're going to read the definitions and head down here to drag and drop those definitions. Drag and drop the definitions where they belong, insert them where they belong. What's happening in the images above, I'm just going to talk about the definitions. I'll go back to the light in just a moment. The definitions are, the word is along the side, and this is meant to represent a solid object, right? And so light traveling down with the arrows, traveling down hits the solid object, and then it bounces off in a different direction. It is a representation of reflection. And of course, I just said the definition out loud. You would go look for that definition to match to the visual that you see here. Here, light waves are passing through. It's called transmission. Here, the light is stopping at the object, right? This is a solid object. And then furthermore and furthermore. So you're going to drag and drop the definitions according to what the vocabulary term is, and you can find that information either in the slides or perhaps in the video, or you can make sense of it by looking at the images that you see. The other part is you're going to drag and drop these arrows here on the left-hand side. You're going to drag and drop them looking at this transverse wave here, and we know that the wave is moving from left to right. And on this side of the wave, right, on this side of the transverse wave is the wavelength increasing, increasing, or decreasing. And you're going to drag whichever arrow that you think, and you're just going to put it right next to it, right? So that we can identify on this side of the EMS, the light wave that's traveling, the wavelength would be increasing, decreasing, whatever you decide. And so there's 3 and 3. There's 3 that would go on this side and 3 that would go on this side to represent what's happening down here with the wave. Then I'm going to move up to the last part of this. This is a little bit lengthier, so I'm going to talk quickly. You can pause or rewind if you miss something, but I am going to speak very quickly about the purpose of this spectrum so that you understand. So radio waves are very large waves. Those are usually the waves that you hear from a tower that is transmitting music or a radio station or a podcast, anything that you listen to traveling in a car. Let's say you're leaving from Las Vegas and you're traveling to Utah or out of the state. At some point in time, if you travel further and further away from the tower where the radio waves are being dispersed in very large amplitudes outward towards your car so that the signal on your car can pick up the wave and you can hear what's happening. Um, those are called radio waves. So that is on the far left side of the spectrum again. It's a representation of what's happening with the wave. These waves carry lots and lots of amplitude so that they can travel greater distances. Radio, or the next would be moving down on the spectrum. It's not even moving down because it is moving down, but these are also just as extreme rays as these. So this is all one wave. Again, this is literally all one wave. This is not multiple waves, radio waves, and then there's a new wave. This is one spectrum of a wave. As we move closer to this part of the wave, maybe something is decreasing slightly. You're looking at microwaves, and not just a microwave in terms of your food being heated up in a microwave. Yes, that does happen, but microwaves can also be other representation of waves. It's not just, it's the particles, the tiny atomic particles in an object, in a solid, in a gas, or a liquid being intensified to do something in a microwaves circumstance. These can also be radio waves because they're very close in amplitude and in wavelength and in energy. So it's just a larger wave, still a large wave, right? It's decreasing in amplitude, but so radio waves can still be microwaves as well. It's just atomic, the small particle of an object vibrating at a high level, which is what happens with your food if you warm something up in a microwave. Those waves are um, those waves are being heated up very rapidly. The particles in your food or the water particles in your food are being heated up or vibrating very, very quickly according to this wave, and thus warming your food up very rapidly. Sorry, it took me a minute to get that out. Moving along. So as we continue to decrease, let's say this is one sun wave, right? One ray of sun. This is it. The next one would be infrared waves, which makes sense because if microwaves are a process of heating particles up in food, right, specifically water, then obviously we're moving along the spectrum in terms of heat, right? Infrared waves, I think we discussed this with our Nearpod recently, that infrared is, yes, those super awesome goggles that FBI or agents wear where they can see in the dark. And yes, they may look purple in terms of what they look like on your video games or what they may look like on TV, but the purpose of an infrared wave, right, even in the goggles, is to sense heat. And since if it's very dark and you can't see anything moving, and let's say, an FBI agent or someone, a military agent puts on infrared goggles, the goggles would show them on the other side that there are very large red objects moving in the dark that they can't see. And obviously, those very red objects would be something that would indicate something's alive, right? Human bodies, we have a temperature, a normal temperature in our bodies, 98.6. So we're always running hot as mammals and as living things. And so someone who puts on infrared goggles would obviously sense something that's red on the other side of the goggle as someone hiding in a place that they can't see, but they can see the red signals coming off of that living object. So those are infrared waves. And as we move again along the spectrum, it makes sense that those are infrared, red being the key term in infrared waves, and heat. Heat is symbolized by fire, which is red or orange in that spectrum, right? So here is where the human eye can visibly see the light that is being passed in a sun ray, right? Again, this is one sun ray. There's only a very small spectrum that we as humans can see with our naked eye. These waves we cannot see. it's not possible for us to see. Our human eyes cannot see these type of waves. This is the smallest area of a wave that we will ever be able to see with our human eyes. That's why they would have to wear night ray goggles to see infrared waves on someone, because we can't see that type of wave with our human eyes. So visible light, we all know that these are the colors of the rainbow. This is the small spectrum of light that we are able to see. I don't think I need to explain that, but what happens here is a lot of absorption or reflection or even transmitting, and what we're able to see depends on the object in which the light is, the wave is hitting the object. Okay, I'll move on. The next one would be ultraviolet light. And now we're getting into maybe decreasing in something, but increasing in something else. I'm not going to give you the answer. I'm pretty sure you can figure it out. But the key word in ultraviolet light would be violet, right? It's on the other end of the rainbow, or the light, the visible light spectrum, which is purple or indigo, or sorry, not indigo, violet. So ultraviolet light would be an example of lava lamps. Lava lamps have ultraviolet light in them, luminescent lights, so to speak. If you've ever had those luminescent stars in your room where, during the day you can't tell, but at night when you turn your light off, you see all the little stars that are glowing. Those are ultraviolet lights. Those are luminescent lights, lights that illuminate um, at a certain perspective, right? So ultraviolet light would be, yes, the light that would be in like lava lamps. Yes. Sorry, I had to pause for a moment. I might go back and edit this because I'm missing a key concept here, and I apologize. I'm going to move on. So ultraviolet light would be, sorry, I'm having a brain. Maybe it's because it's late, but I'm going to move on. So X-rays. X-rays, we're getting into dangerous territory here with X-rays and gamma rays, and we can see that there's something that's increasing and that's happening down here with this wave. The waves are becoming more close and close together, which is dangerous levels of exposure to a wave, right? Waves can do damage and can be harmful to us. We know that, obviously. X-rays they're at a level, such a microscopic level, that X-rays can be, uh, the wave can travel through us, not through bone, but through our flesh and our skin. And we use this obviously in medical field so that we can see through. If you were to break a bone, if you were to fracture something, even when you go into the dentist, they use X-rays. And if you think about it, unless they are scanning your entire body, if you go to the dentist, they lay that big heavy mat across your chest before they take pictures of your teeth, because they are exposing you to very high frequencies of X-rays that could possibly damage your inside. So they have to be very strategic in how they expose you to these intense waves, because they can damage organs in your body that you need to stay alive. So those are X-rays. And then gamma rays, you've guessed it, you can connect it to the hazardous waste, or the nuclear waste that we talked about when it came to um, transporting waste across the country, right? Where, again, yeah, my brain is like falling asleep. But gamma rays would be the toxic waste that we have at Yucca Mountain, right? This is the nuclear exposure, the radioactive waves that is highly contagious and and dangerous for us to be exposed to. That would be that radioactive. Those radioactive elements that we should never be exposed to. Those are gamma rays, or waves that have passed at the most extreme height of the wave. All right, I will add a small clip just with my voice about ultraviolet waves that I forgot, but I'm going to end this video because I don't want it to be extremely long for you so that you get bored really quickly. And I do apologize. It is late. I shouldn't be recording this late, but there is your lesson for the first sheet. The second sheet, it's the same wave as the other sheet. You're just rearranging the following images to display their level of energy along the electromagnetic spectrum. And I talked about it just a smidge. So you're going to drag and drop these images just below the the wave that you see here. You can drag and drop them where you think they would be best represented on the wave, right? Where would radio waves land? Would it be further down here on the wave, further down here? And then, yes, so you are dragging and dropping those, and then you're just answering the questions below. And there are choices for you with these questions. You're going to pick A, B, or C, and then explain your choice underneath it. I know it's not a big area, but remember all this is typing area as well. And that's it. I will see you in the next video.